As the Earth warms, we're not only tracking rising temperature, we are observing how the warming alters the natural system across region, time, and ecosystems. Climate driven environmental impacts are a physical consequence of a warming planet. They are measurable, escalating, and distributed unevenly across geography and time. Let's explore how these impact manifests and what pattern matters most for climate risk professionals. The first one is distribution across geographies. So climate impacts do not occur uniformly. Geography plays a key role in determining which regions are exposed and how severely they are affected. For example, low-lying coastal areas are more vulnerable to sea level rises, saltwater intrusion, and storm surges. Arid and semi-arid regions, so which are drier regions, have greater exposure to prolonged drought and land degradation. Polar zones also warm faster than global averages, driving ice loss and ecosystem shifts. Tropical zones are also at an increased risk of intensified cyclones, coral bleaching, and precipitation extremes. So the key takeaway here is that climate change does not impact everyone uniformly. It is impacted by where you live and the geography. The second consideration is frequency and intensity. Many climate hazards are not only more widespread, but they are becoming more frequent and more intense. For example, heat waves are now hotter, longer, and more common. Heavy rainfall events are increasing in frequency, often leading to flash floods. Tropical cyclones are showing higher peak intensities and slower movement, increasing damage. Droughts are intensifying due to increased evaporation and changes in precipitation patterns, and wildfires are expanding in range, duration, and destructiveness. Another consideration is looking at temporal dynamics. So climate change impacts unfold over different timescales. Some are more immediate and acute, like hurricanes and flash floods, while others are chronic and cumulative, such as glacier melt, ocean acidification, or biodiversity loss. Importantly, these effects will compound over time. So for example, long-term warming drives permafrost thaws, which releases methane and accelerates warming further. So for the exam, you have to connect cause to effect. A core task for a SCR candidate is to connect observed environmental outcomes back to the underlying climate drivers. For example, an outcome could be increased precipitation intensity, and that is a result of warmer atmosphere holding more moisture. More wildfires could be a result of higher temperature and longer dry seasons, and coral bleaching may be a result of ocean heat content and marine heat waves. Understanding these causal links is essential when evaluating physical climate risk at both the asset and portfolio levels, a concept that we will cover in the later chapters.